Hey everybody, just a couple of short videos to show you some stuff that I didn't get a chance to say at the end of our last conversation. So this is about maximum intensity projections and sort of a starting point for looking at the data set that we already have on disk. So we can go over how to get exactly to the data and where it's located the next time, but for now I just want to explain some of the principles, and hopefully if you're on a Windows setup, you'll be able to replicate some of these things. Probably not the Unixy stuff, but the MATLAB things that I want to show you in a couple of minutes. Okay, so I have a folder which I have cloned from the GitHub repository that I've made for this project, and I can explain that in a little bit of detail as well. So the only reason I need you to know this for the time being is that that's where some notes are kept, which you can also look at on the online page. And there's these two M files, which is a starting point for some MATLAB code that we could start developing in your 3 independent projects. And I've also made sort of a shortcut. So this is called a symbolic link, but it's a shortcut really to 2 folders. One which contains this angio data set that I've uploaded on the Teams space. And the other one is a folder which is also up there, which is actually derived from the paper that I linked, the PDF about this probabilistic atlas of the different vessels in the brain. Okay, so I set you a little challenge to superimpose those images that we have. So have a T2 weighted image underneath, which is a very good anatomical image, and then superimposed on that, you could look at one of those magnetic resonance angiography images, the MRAs, which are also kind of anatomical images, and they have this very special property that blood vessels, arteries, are very bright in them. Okay, so I just do ls here and change directory into this angio folder. Here are the files that you should be able to see. A couple of JPEG images and PNGs, so you know what to look for. And the sort of the trick I wanted you to play around with, which hopefully you'll sort of become familiar with if you haven't already, is to use FSLEYES as command line tool for the viewer to launch the viewer program. Show the T2 weighted image, so T2WI, and then if you give it a second image on top, then it will load it as a layer into the viewer program, right? Okay, so and in this case, I'm actually just going to use the angio image that's there, .nii. And if you look at the documentation for FSLEYES, you can actually specify some parameters to how these images should be displayed. In particular, there's an option called CM, which stands for color map. And if you want red colors, that color map is called hot. And we can also set an alpha values, which is the transparency of that image that gets displayed. And if I want to make it sort of semi-transparent, I can add the 50, okay? Hopefully you'll remember what the ampersand is all about. And the ampersand lets you send things to the background so we can keep control of the shell, okay? So we hit return here, launches this process. And I'll take a second to load the images in. Should be pretty nice. If you look down here in the bottom left, right, you can see there's 2 layers. One of them T2 weighted, which is underneath, and the angio on top. They have slightly different dimensions, but they display. With the angio one selected, you can see that the opacity value is at 50%. So if I can yank that up and go down. So if we now start manipulating the range of values that are actually being displayed, right? So in the red image, rather than showing everything that's 0 all the way to the highest intensity, if I only show the high intensity values by cutting everything else below off, so if I set this to 1500, so this is a value I looked at before, it seems to work, you can see that the only thing that really remains are these very bright spots. So they're actually a bit hard to see, so let me now turn the opacity up to 50, from 50 to 100. And if I scrub the images down, you can see this very particular pattern of the blood vessels sort of as we're traveling from top to bottom on these images, okay? And so one really cool way to look at that is to go through the slices, right? So let me switch this particular view off. There's a movie mode as well, where you can actually scrub through the images this way and record an animated, like a GIF, basically, an animated GIF of what's going on. Okay, so this is one way in which you can actually start interacting with the data. Okay, so that's already the first bit. So you can play around a little bit with the command line arguments of FSLEYES. So it's worthwhile learning that, because you're probably going to use them if you use the FSL tools for some aspects of displaying them. And one way to do that is to just look at FSLEYES, FSLEYES. So I can type -H, which gives you lots and lots of options here. There's also full help, which gives you, so if you type FSLEYES -- full help, you get all the possible options that you could use with this particular program to change the things, right? So if you look at the online documentation for this tool, it's very powerful. It might be the way in which you might actually want to create some of the images for your final report, so it's worthwhile playing around with that. Okay. All right, so that's the first thing. But what I want to do now, actually, is I'll just stop and I'll quickly switch on my iPad so I can do a quick drawing of what this maximum intensity projection is about. So hopefully you've been reading that. So just give me a minute while I do that, and then I'll see you in the next clip. All right, so what's up with this maximum intensity projection? Okay, so let me just do a couple of scribbles so you understand what's going on here. So let's imagine we have sort of a headlight object. The nose is up here, so the eyes are there. And I've just shown you that the blood vessels have this very particular sort of shape that's there. Maybe there's a bit here, something coming out through there, right? And so the question now is, how can you visualize what's going on in this 3D structure in a two-dimensional image that we want to display on the screen? And so one thing the radiologists have started doing when these images became available through CT first and now with MRI as well is, so it turns out if you take a projection through this image, so if you imagine looking at a screen, let's say on the side of the head, and you trace through the object at right angles at every point here, and whatever the highest value, the maximum value, maximum intensity you encounter through the object, that's the one you keep and you project here. That's called a maximum intensity projection. Okay, so not very much interesting stuff happening here, but as soon as you hit these things here, which are very bright in the image, you will end up with this essentially a line here, which is sort of the projection of those objects onto a perpendicular screen. Okay, so you can see how that works there. Right? I'm switching back to black because there's nothing of interest in this intermediate bit here. Okay, so these projections all result in very low values, right? Because the intensities are only high in the blood vessels. And as soon as we come to that object down here, we're back at ending up with sort of encountering very high intensities as we project through, and that's what ends up here. Okay, so you can already see in this diagram that I've drawn here, this maximum intensity projection is sort of blind to things that are hidden behind something else. Okay, so if you imagine this is a kind of shadow, right? If there's two things that could give shadow to a light source that's over here, right? Those two shadows are going to be identical, right? And they overlap, so it's very difficult to see what's actually going on. Okay, but if I now change the angle in which I do this projection to over here, for example, then you can start seeing that things that were confounded in this particular direction here are now not confounded when I go down here, right? So if I just draw the maximum intensity projection here, I'll end up with the shadow due to this thing here, and something there, and something there, okay? And so the clinicians often take these maximum intensity projections at lots of different angles. Okay, so let me just make a new image here so we have a clean. So if you imagine having this particular guy here again, right, with the bright things in the middle here somewhere, right? It doesn't really matter what the details are here. They would start doing a projection at this angle, at this angle, at another angle, at another angle, another angle, right? And if you actually look at this first projection, the second one, the third one, the fourth one, and the fifth one in sequence, it's as if you're stepping around the head and you're seeing these projections in 3D, and it becomes very easy to tell apart what the 3D structure is, okay? So that's sort of a perceptual consequence of how our visual system works, okay? So for starters, what I want you to think about is, if this is an image, right, then we're actually talking about a cube of data or a slice of data, if we're just thinking about a slice in 2D. How, in MATLAB, could you get the maximum intensity projection, which would just be a line, right, here, or a line there, if this is just a table of numbers, a matrix of numbers? What's the operation that you'd have to do in MATLAB to achieve that? Okay, so that's sort of the first thing I want you to think about. Then, if you are happy with this idea in 2D, and don't worry if you're not, we can talk about it in a little while. Imagine what the situation looks like when you're doing this in 3D, right? Okay, so now we have a sort of image embedded in here, and let's imagine we want to take a projection that's in this particular orientation there, right? So over there. What does this mean in terms of MATLAB operations, given that we have like a 3D cube of data, okay? And so the general ideas I want you to think about in terms of coming back to MATLAB for this, which I will do in my next recording, is you need to think about doing operations in 1, 2, 3 dimensions, right? In particular, also, you know, dimensionality reduction operations. And it might help you to think a little bit about, you know, if this cube of data was actually called a variable called data, how does the indexing work on these things, right? So there's a first dimension, a second dimension, and a third one, okay? And how can we achieve looking at values that are the maximum value in a particular direction, okay? And so we covered some of that stuff in the MATLAB lecture, so it's worth going back over that material if you find it